This pandemic has brought change in education. Classrooms are now vacant and students are forced to homeschooling. The school, which was once filled with thousands of students, lies empty. But the science department is leading the way to bring quality education to our learners, despite the difficulties caused by the current situation. Science lessons shall now be streamed using online platforms, making students learn the concept right at their homes. Exploring the amazing world of science through investigation and experimentation, giving our students a virtual laboratory experience, making them curious about the world they live in. Teaching you using available science laboratory equipment and apparatuses, virtual and 3D models, multimedia presentations, dioramas, and other science visual aids and materials for a different and a unique kind of learning environment. Science matters, where learning never stops. Where learning never stops.
Nakasakay ka na ba sa roller coaster ride na katulad nito? Exciting, di ba? Ano kayang science concept ang mayroon sa mga ganitong rides? Yan ang ating aaralin sa lesson na ito. Kaya tutok lang dito sa Science Matters, where learning never stops. When work is done upon an object, that object gains energy. The energy acquired by the objects upon which work is done is known as mechanical energy. Like work, energy is measured in joules. Energy appears in many forms. For now, we will focus on mechanical energy, the form of energy due to the relative position of interacting objects or to their motion. Mechanical energy may be in the form of either potential energy or kinetic energy. Potential energy is attributed to the mass and position of an object. Mathematically, potential energy is the product of an object's mass, height, and acceleration due to gravity with a constant value of 9.8 meters per second squared, while kinetic energy is associated with the mass and speed of the object. Kinetic energy is 1/2 times the product of an object's mass and the square of its velocity. Thus, we say that mechanical energy depends on an object's changing position and motion, or the conversion between the object's potential energy and kinetic energy. As already mentioned, the mechanical energy of an object can be the result of its motion, and/or the result of its stored energy of position. Considering the animation, we can say that the total mechanical energy of an object is the sum of its potential and kinetic energies. In equation form, total mechanical energy is equal to potential energy plus kinetic energy. Or simply, TME is equal to PE plus KE. Since PE is equal to mgh and KE is equal to 1/2 mv squared, then TME is also equal to mgh plus 1/2 mv squared. Now, let's analyze this situation. The diagram depicts the motion of Ben, a ski jumper, as he glides down the hill and makes one of his record-setting jumps. The total mechanical energy of Ben is the sum of his potential and kinetic energies. May napansin ba kayo sa total mechanical energy ni Ben sa bawat point of his travel? Tama! The two forms of energy sum up to 50,000 joules in each point of travel. Ibig sabihin, sa bawat point of travel, ang total mechanical energy ay hindi nagbabago. Ito ang tinatawag na conservation of mechanical energy. A roller coaster operates on this same principle of energy transformation. Work is initially done on a roller coaster car to lift to its initial summit. Once lifted to the top of the summit, the roller coaster car has a large quantity of potential energy and virtually no kinetic energy. If it can be assumed that no external forces are doing work upon the car as it travels from the initial summit to the end of the track, then the total mechanical energy of the roller coaster car is conserved. Conservation of energy on a roller coaster ride means that the total amount of mechanical energy is the same at every location along the track. The amount of kinetic energy and the amount of potential energy is constantly changing. Yet, the sum of the kinetic and potential energies is everywhere the same. And that is how mechanical energy is conserved in roller coaster rides. Sa palagay mo, anong mga activities pa kaya ang gumagamit ng principle of conservation of mechanical energy? Don't forget to like, share, and subscribe our channel, Dasma North Science, so you won't miss any video lesson. I am Ma'am Janice Reyes, your grade 9 science teacher, only here at Science Matters, where learning never stops.
Science matters, where learning never